let's start with running a status, and we can see how the system is configured. Now we can see a couple of interesting things here. We have 2 sockets. Turbo is on at the hardware level, and it is engaged at the operating system level. We can see that hyperthreading is off at the hardware level, and so of course it has to be disengaged at the OS level. We have 24 real cores, and all 24 of those are active. We of course have 0 hypercores because hyperthreading is turned off. That said, we can see other interesting things about the cores here, such as the scaling governor that's in use, minimum and maximum frequencies. We can see that there is no limit to the C states the machine can go to, and that C1E is disabled. So, Intel P state, we've got a little info here. It says that it's recommended that we use acpi-cpu-freq, and so if we run this with start, it will tell us that we need to create a configuration file, and then once we create the configuration file, we can run start again, and it'll give us instructions on how to enable acpi-cpu-freq. There we go. So it says we need to create the configuration file. We'll just do that by running the command with the init script with the defaults option. And it has created that file. Now we're not going to look at it right now. We'll take a look at that in a minute, but I can tell you that it's heavily commented. All of the settings are commented out, as the defaults are generally appropriate, at least as a starting point. So now if we run it again with start, it will tell us here's how to change the configuration to use Intel P state. Now I'm using a tool here called Screen that allows me to have multiple windows open at the same time within a single terminal session. So it also allows me to do things like scroll up and down within the output. So here's what we're going to do. We're going to edit the configuration file for grub. I'm going to switch over to another window here, and just paste that in. And let's see, and it says we need to find grub command line Linux and add this bit to the end. Okay, so I'm going to copy that. We'll switch over to the screen. We've got grub command line Linux here, so we'll jump to the end. Let me set the text width to 0 so that it doesn't try to wrap the line. We'll add that entry to the end of the line, save, and quit. Now let's see, what does it want us to do? So now it says we need to run a command to actually update the boot time settings. The file we just edited tells grub what settings it should put into place, and so then the next step is to run a command that will take those settings and apply them to all of the boot entries that it's going to put into place, that will actually see at boot time. For example, if you have 3 kernels, it will apply those same settings to each of the 3 kernels. Okay, now since we're on CentOS, we need to follow this procedure here. So we're going to first figure out where that configuration file is. Okay, now we're going to take a look at the file. Right, okay. And in a quick look at it here, we can see that its contents are quite different, and it's fairly complex. Hence the benefit of having the other file that we edit and then let the grub update tool automatically put settings into here. All right, now we're going to run that grub update tool, and for CentOS, Red Hat, and Friends, it looks like that. Here we go. And you can see it's finding each of the kernels that are in place and updating entries for each of those. The warning messages there are not, you may or may not see those. In my case, those are unrelated to what we're doing, and they're harmless. Now, we're just going to verify that those settings got put into the actual boot time grub configuration file, and there they are. Excellent. So our next step would be to reboot this machine, and then we could actually apply settings and use the start option with set CPU state. But rather than taking the time to do that here, I've got another machine that has already been rebooted, and let's go ahead and jump over to it. That machine would be data node 0103. And I'll clear the screen here. I'll go ahead and do that on the other side too. Okay, now in our first window, and I also happen to have already installed hpc-goodies-cpu package. So we'll go ahead and start with set CPU state, defaults, create that defaults file. Now we can run set CPU state with start, and boom. Now let's see, where does that put us? That puts us with, we can see we have the two sockets. Turbo is on at the hardware level and in the OS, and we can see that there are 24 cores that are turbo enabled. Hyperthreading is on at the hardware level, but off. So we can see that that is actually probably the way that you want to run in a high-performance environment. But this tool gives you the ability to make that change on the fly and to try various settings. Total number of real cores, active real cores are both 24. We have 24 total hypercores, but none of them are active, okay, because hyperthreading is turned off. Our scaling driver is acpi-cpu-freq, and which again gives us better control over these all of these settings. We're currently using the on-demand scaling governor, and we may want to change that to performance. And we can see the maximum and minimum frequency setting for all the cores. The C state is set to not go deeper than 2, and C1E is disabled. Now let's do something interesting. Are you familiar with the tool? It's called Watch. Watch is kind of neat. It lets you run a command in a cycle, so it'll keep running the command every 2 seconds by default. So if I run watch date, we can see that right up here that every 2 seconds it's being run again, and we see the fresh output. Now I'm going to use that tool here to allow us to watch the way that we change things by adjusting settings in the configuration file. So I'm going to run set CPU state start to apply settings. And then I'm going to run set CPU state status to show us what those settings are, or what the current settings are. And I'm going to run that in a loop by having watch execute that. Okay. Now I'm going to do another cool thing here with screen. I'm going to create a split screen. And on the left side, we're watching the settings. And on the right side, we're going to have a window where we edit the configuration file. Okay, so let's just try changing the governor. Making a change to the configuration file is as simple as setting variables. So now we can see it's using the performance governor, okay, on all of the cores. Let's tell it to turn turbo off. Okay, now we can see up here, turbo is on. Okay, I'm going to write those changes, and now we can see turbo is off. All right, that's still on at the hardware level, but we've disabled it at the operating system level. Kind of cool, huh? So now, even though we probably don't want this in a production high-performance environment, let's see what happens when we turn hyperthreading on. You might find that it has advantages for your particular application. This gives you the ability to test and try on the fly without having to go through a reboot every single time. So now we have 24 real cores, and all 24 are active. We have 24 hypercores, and all 24 of those are active as well. Okay, now let's go down. We're going to skip over that one for a minute. We're going to go down to max frequency. Let's say that we want the maximum frequency to be, let's see, it says it's this particular system is running at 2500. Now we can actually do this. We can ask it to tell us show freaks. It will show us what are the available frequencies that we can specify. So let's just pick 2 gigahertz even. Okay, so we'll say max freak should be 2 gigahertz. And boom, it changes over here on the left. Okay, why would you want to do that? Well, let's say that you have a power constraint or a cooling constraint in your data center, and you have a large number of machines doing a job for an extended period of time that you know tends to generate a lot of heat. Now, you are less concerned about, maybe it's reasonable to allow the job to run a little bit longer if you are able to keep it within an appropriate heat envelope. This could be one way of doing that, and I'll show you another one in a minute. We can also specify the minimum frequency. Let's say we don't ever want it to go down below, let's see, what were the freaks here? Let's say 1400, okay? We don't ever want it to drop below 1400. And boom, we can see that change was made. So various reasons for that you might choose to make those settings, but you have the option here. Let's go down and we'll put those back to their defaults. Having the C state set to 2 is a reasonable compromise between power consumption and allowing for high performance of latency sensitive environments, such as RDMA access of GPFS file systems over InfiniBand. Lastly, we have C1E. For performance reasons, we want this to be disabled, but we have the option here to enable it. As we can see on the left side now, it is enabled. but we'll want to leave that off for production purposes. Again, being able to make all of these changes on the fly can be very handy, and it means enabling some things at the BIOS level that you would normally think of turning off and leaving off. This should be accompanied with our Lenovo ASU or UEFI settings best practices configuration. Now let's take a look at this last setting. Limit real cores. This allows us to turn off all of the real cores except for the number we specify. Let's say that you have a software that is licensed for 8 cores, but your system actually has 24. So this gives you a way to disable all of the cores except for the number that you need, in this case 8. Now you'll notice that when we disable the real cores, the hypercores follow suit, and we disable them as well. Okay, I believe that's all that we have for today. Hope you found this helpful. Thanks.